Welcome to the MediTrust prototype demo, a system designed to support healthcare professional in critical tasks like text summarization, assistant, and validating prescription. This demo showcased the initial feature of MediTrust AI, which aim to help streamline healthcare processes, ensuring trustworthy and efficient decision-making support for medical professionals. Is the growing healthcare industry faces different kind of challenges, such as an aging population, resource constraint, overloaded professionals, and psychological pressures. There is an increasing need for the AI-powered solution. This demo addresses some of these challenges by offering a AI-driven support to healthcare professionals, reducing the burden and enhancing efficiency through automated tasks like summarization, anonymization, and decision validation. So our project basically in this prototype, we will demonstrate key features such as synthetic patient record generation, medical record collection, and essential feature like anonymization, patient summarization, and medicine recommendation. Additionally, two other important modules like health chatbot and doctor-patient conversation are under development to further enhance the overall workflow. Let's now explore the feature of the MediaTrust prototype AI. Okay, let's first look at the development environment. Let's suppose this is our whole MediaTrust AI folder in which we divided each of the feature in different modules. So this is our data modules, and this data module is actually right now I'm using a JSNL, JSON, and Excel file. So, but some of the data actually, most of the data, this medicine data we have generated, we have collected by using Google Colab, and we use the FDA, Federal Drug Authority's APIs. Nearly we collected 25,100 drug information. And this is actually the patient record data, both in Excel and the JSNL format we have collected by using a GPT. Actually, we generated this data by using a GPT. So right now I will show you the GitHub code, how we have generated this data, especially this is the organization of our data, and it's available on the public, our private MediaTrust AI repository. As you can see that this data generation process is organized in a different modules. Like we will say that for example, I can guide you through its functionality in the repository. We have a different Python script that handle different steps of synthetic data generation, like simulating patient history and medical visits, etc. For instance, let's briefly explore one script responsible for cleaning the patient data set. So we have medical cleaned important this data set. This script reads as CSV files. So this is the part basically where we are reading the CSV file and remove rows where the edge is unknown, and then save the clean data into a new file. Here is a quick look out at the key part of the script. The script start by reading a CSV files containing a different patient data, identify the rows where the patient's age is unknown, remove those rows, and then save both the clean data set and the removed rows into a separate file. This ensures that the data is ready for further processing without any missing or incomplete records. So basically, we have used this before that we already generate the data, but most of time you are not getting good data. So we were continuously iteratively improving the data. The next part that basically is about the medicine data collection, which basically where we handle medicine record collection rather than synthetic data generation. I will show you how we use Google Colab to collect a large number of medicine records from the OpenFDA API. You can see here, like this is the link available of the Open API. On the screen, you can see the Python script being executed in Google Colab. It retrieved medicine records by making a pagination request to the OpenFDI. The script is designed to extract up to 100,000 records, but of course, we did not get that much medicine from the FDI record, so it was only 25,100 medicine. So we just collected those medicine. I will show you like how you can. I'm going to execute it and will show that how you can collect it. So this is the required file that we need to install it, and we have to like wait for a couple of minutes. Meanwhile, I will pause my recording, and when it's done, I will come again and show you how everything have been happened. Okay. Surprisingly, it was quite fast. So we got the medicine record and just we need to simply save it. Before that, right now you can also see that like um, this was some of the information. And here, like for example, 20 up to 26,000 when the statistics went there, we were not able to extract the information from this. So right now, like we got it, and I will show you like here in my download folder that we got this FDI medication. So here is the newly FDI medication that consists of the medical name, generic name, and some manufacturer, purpose of use, and warning, and source we have used from the FDI. So there are a couple of other websites and ways you can also use the correct medicine record from there. But of course, this need to be verified with the health care professionals. Meanwhile, I will also show you that like how clean data for the our synthetic data will be look like. It is more structured way in the Excel, but on some unstructured way in the JSNL. So you find several problems when you are executing with it. So like here you can see that like we started from a patient ID and patient may have a like multiple visits. Then the age group for deciding a different kind of medicine, their address. So the address could be changed with the passage of time, but right now we did not play with much about that. And this is the information, demographic information is also we need to anonymize. I will show later on that how we did it. So like the blood pressure for the every visit and the temperature for every visit, weight for the every visit, height, of course, it's going to be a not unchanged. And the similarly, different symptoms for the every visit. And if they have a like persistent disease or some chronic disease, some genetic disease, we also have those record as well. So you can also see that like the procedures, what procedures they have followed the doctors and what they have recommended in a medical notes. We also generated these kind of things. So the overall, you can see that like we have a nearly 500,000 records that actually over the 500,000 records we have. So this is the data that is a very comprehensive data. And right now, if you are using a CPU, so it is not like easy to process this data with even with a simple query. In my case, I'm using the CPU. So like the responses will be the bit slow. So this is all about our generated data. Here I show you like how we collected the medicine data and how we have generated the synthetic data. So now we will move on the next step. Like I will show the interface of application that we have developed. And also I will show that the like how the different functionalities can be performed. Okay, let's give you a quick tour of my development environment. As I mentioned earlier that we have uh, performed different functionalities in a different way. For example, I use the different model for generating synthetic data, and also I use the different LLMs models, small language models, and even like a rule-based techniques for summarizing the data. But anyway, like I will show the clean output how we have done. For example, this is the our demo one that we have prepared. In this demo one, we have a main file. This main file is responsible for generating the interface for the whole application. We use the Gradio for this purpose. Gradio is not much like I will say that like a flexible, but it's good for a demo purpose. And then we are reading directly data from this XLS file, like a patient record. Here you can find that, okay, here in the data. And then we have a in a medicine data files here. So we are recording the patient information from this file and medicine information from this medicine data file. So the application will produce the different kind of like output and also not the output, it will consist on the different tabs. So each of the tab is responsible for the different functionality that we have defined here. Like these are the Gradio interface. For example, first of all, the search tab, then we have a different kind of random data extraction tab, and anonymization and de-anonymization and different features, other different features. Let me go on a like a root of the application, and I will start showing everything from there to you. Okay, so we have our information in the demo, and now I will list down. So are using the Python 3, then main.py. Let's execute and wait for a couple of seconds. Okay, so this is now your local URL have been generated. We are clicking on this and we will get this information. Right now, for example, as I mentioned that the data is too big, I am just generating the extracting first 20 record about the medicine and then the first 20 record about some drugs. So what we can do it like we just generate both of at the same time and we can wait for a while. So it will retrieve us 20 patient IDs are the 20 drug names that are like randomly generated. Okay, we got it information about the 20 patient IDs and then the 20 patient drugs. So simply what if we want to share, like find the more detail about these ID or what information we can get it. So I just want to put here, I already executed with this, meanwhile, I already executed this, I will set the patient ID record. You can see here that like this is the patient information that we read it from the Excel file, and like this information, every visit wise, we organize into a visit wise. So for example, this patient have a several record, or for example, let's have a more than 5 or 6 record that we have generated here. So let's see like how we can anonymize it. Again, I already executed this one, so we will not waste some time during the execution. So we got it. And this was the information that we did anonymization. I will go back literally with our anonymization file. So how we can perform the anonymization and de-anonymization. So basically anonymization, we are using SPSCY for the anonymization, and also we are using like a name entity relation model here. So we executed this model, and this is going to be like reading the whole script for the specific whole data set for the specific patient, and then it's trying to anonymize, and it's actually anonymize the name, date of birth, address, and medical notes. If sometimes there is a name, address, or some other information that is not aligned with the GDPR. So we are also scanning the medical note. If there is any name entity relation, it's like anonymizing it. So once it's all done, it's give us back like a anonymized script. So can you can also see that like here we can find the anonymization script at some places. For example, you can see here that this is a medical patient note, and somewhere here this was a kind of data that should be anonymized. It's replaced with this pseudonym. And similarly, it goes for the every visit, and if they find like any anonymized information, is just simply did it. For this, like anonymization, when you are going to de-anonymize, you also need something that is called like a token map. We are generating a token map as well. The anonymized information for the actual name is going to this token, actual address is going to this token, and actual so like a phone number, email address can also be going on this token. And whenever you are de-anonymizing it, it's just simply return back. So like this, for example, I also did the de-anonymization for the same. And you can see that like we did not anonymize the patient ID, but you can also do the patient ID anonymization. I just did it on purpose that we can also see that it's correctly anonymized or de-anonymized. Like, okay, so this was the guy, and this is his ID number, and then we get back the like address, and also like everywhere where it was required, some information we are getting back. So this is the one patient record. I also have a one script in the same like a project that we can anonymize and de-anonymize the whole file. For example, like these 500,000 patient record that we have generated, and if you have some sort of the actual record of couple of million people, that can also be generated just in a couple of clicks. So this is the anonymization. And next I will move on the patient summary. Okay, this is our patient summary module. This summary module have a different kind of controller here. Let's suppose like here the patient ID that you want to like summarize his or her information. The basic motivation behind that, like how you can summarize that much record, that long record. For example, here you can see that the actual information could be very long here. So like, for example, if someone is like a 60, 70-year old, he may have a 50, 60, or maybe more than that visit to doctor, and every like visit, they have a lot of information there. So how they can process this whole information? So for this, basically, what I did, I actually make this small like interface. First of all, you can put the ID of the patient. Let's again push the same guide so we can relate that how this is gonna be happen. And then you can choose how many visit you want to display. Sorry, I will say that how many recent visit to display, or how many recent visits you want to summarize. Let's suppose like we are going for the 6, and then you can also select that, or maybe I will say the doctor can select that gender or whatever initial condition. Let's suppose like we are randomly selecting some of the information from here, and then you can also I will select the way format structure, what kind of format you are looking for, like bullet points or paragraph. Let's do for the paragraphs. And of course, you can also put a lot of other information here. So what actual doctor needed in the full-fledged version, for example, uh, like what kind of relevance they want to find it, the accuracy, and some other places. So right now, like we can improve this patient summary in a different way. Like we can also provide a multi-agent approach. Right now, I will also show you the behind the scene what is going here. In a patient summary, like this is our patient summary modules, in which basically I use the T5 small model. Just only the reason was that like we can I'm using like less resources, so you can also access the like a GPU based, so that time you can also use the more mature models. So I'm just for the demo purpose I use the T5 small model. This T5 small model can like summarize the information according to the feedback what he is getting from the interface. So this is the script that I was right now showing, that like how you can what you can select accordingly, it will perform it. So for example, here we are using a T5 model to generate the LLM based summary. So your model could be something else. You just need to change the model name here. And you can also use the pre-trained model, or you can use the fine-tuned model for this purpose. So here you just need to change the model name, and whenever it will be done, so it will give you the return the summary. So here we have another summarize selected visit with LLM. Like this is the module. So how many like a visit we were selecting there. So this was the like a three visit, four visit, or whatever the visit they are using. So this is the small chunk, and again, this is also integrated with the I will say that like a main module as well. So the patient summary again you are displaying here. So this is the section that yeah, actually this is the back end of the GUI that you just saw here. So here is our summary information. So like you can see that like so in a first visit that was happening, the mostly is the medicine was recommended. So you got the information about this. You can also get the like a very small information about thyroid function test, medical notes, etc. So whatever the information they are getting, again, as much as you are using the model like a mature LLM model, you can get the more better summary for that. So that is also context aware. So this is our like a next plan that if we are going for the full-fledged application, we will also develop the I will say that like we will choose the more mature model with the heavy resources so we can get the contextual aware summary for the patients. Okay, next is our the medicine recommendation feature that I will show shortly. Okay, so this is our like a next feature that we are providing prescription validation. In this prescription validation, we need to provide like a medicine name. What is the medicine name? Normally, you can only provide the first two, three letters, and then also yeah, you can also provide the full name as well, and then the patient ID. So I did not show all the detail here, like a summarization and other information for the medical summarization, etc. But it is how it works. Basically, this module will take the medicine this like a feature will take the medicine warnings and other information, and also the patient ID. So this system automatically check that if this medicine have the conflict with a patient information or not. If this is there is some sort of the conflict, it will not recommend. And if there is no conflict, then the prescription for this is a valid based on the available data. You will get the message like this. So next I will show you that like our two ongoing component that is actually about the chatbot and also about the like doctor patient conversation. And I will also share our plan that how we are planning to proceed further with it. Okay, let's first clear the previous information here, and now we move on another component of our system. This is in a GSI. Let's I put the SL like list all the folder and subfolder. Then let me go on a SRC. I will find what is we have for here. And in SRC, in an interface is a GUI SCRC. I'm going to run the hospital management. This is actually the full-fledged module where we are developing several other features as well. So Python pre-test hospital management.py. So here we go. But this will take some time to load because we are using a 8 billion model. So let's see, I will bit explore that how this is gonna be work for you guys. First of all, I need to go on a chatbot because I'm going to show the functionality of the chatbot. Here you can see that like we are using a Llama 3 Open Bio LLM 8 billion parameters. And because every time we cannot execute the full-fledged model, it takes like at least more than 30 minutes to execute full model on this system specs. But if you are doing offloading, so probably you will get like a model up and running in hardly in like less than 2 minutes. So this is the like a model reference directly we are using. We actually we did not I will say that localize it right now, but I also use some localized models for getting a similar output. And here we instruct the LLM model how we are going to behave it, and then we will get the output from it. Actually, it did not take too much time. It's like nearly 20 seconds it took, and we got it. So now, we got the local URL, and we just need to jump on this URL, and we will get some again the same features of the system. Here we also visualizing more, as I was mentioning that anonymization patient, and then you can just generate the JSON map. So you will get the information. Anyway, we are coming on this health chatbot. So you can ask the question, but right now it's not fully functional. So I will say that we will not get the response here. So this was our health chat bot. That is our like a future plan, and then we are working on the doctor-patient conversation. This is also another module that actually the purpose of this module again is to low down the pressure from the doctor. He really don't need to type the things. For example, there is a conversation between the doctor and the patient, and uh, clear permission of the patient, the doctor will be allowed to record it. And whenever they record it, after that, there will be a generated the text from the both patient. It could be in any language, for example, Finnish language, some other Nordic language, or English language. Then the doctor will see, and our summarizer module will extract the relevant information from this converted text, and after the approval of doctor, it will be stored in the database, or it will be stored in the patient history. So right now this module is also under construction. For example, we did not provide the doctor patient conversation module fully up working right now. So that's it about the demonstration of my project.